Hello everyone, and welcome back to now our fourth unit of review videos for the AP Stats exam this year. Unit 4 covers probability, which is a really big unit in terms of both the curriculum as well as the AP exam. One very important thing, you are guaranteed a free response question on this topic. This umbrella is huge, so I broke it down into 5 separate videos for you. But mostly the biggest thing with this unit is going to be recognizing which rule you have to use, whether that's binomial, geometric, one of the standard probability rules that are on the formula sheet. The nice part about the unit as a whole is that almost every single formula you need is provided for you. So there's not a lot of memorization needed on your part, but you need to be able to apply those in the right scenarios in order to get full credit. The other nice part about this unit, in all honesty, is that we're finally starting to do some math. In all the previous units, it's been a lot of describing and descriptive things like writing paragraphs about describing graphs, but now we actually get to do some calculations and have some certainty in our lives. So this very first slideshow here is just going to cover some of the real basics of probability and some notation. And then the later videos will get into some more specifics about what type of formulas are specific to each distribution and also some of the other problem types you might see. So just to go over first, some definitions and notation. Very specifically, the notation that AP uses looks like function notation. So it looks like this. And this represents the probability of A. Literally like read, just like function notation from Algebra 1 and Algebra 2. A is an event. The word event just means literally the thing that you care about finding the probability of. You know, whether that's like the chance of rain in a certain area, the probability of flipping a coin and landing on heads twice in a row, the probability that someone is age 31 to 35 and also has a bachelor's degree. That is an event, right? Anything that is just what you are interested in finding the probability of. A sample space represents the set of all possible outcomes. So you'll see these a couple of different ways. One way that you'll see a sample space is a Venn diagram, which I'm going to draw one of these later. You guys have seen one of these before. I apologize for my dog right now. The other way that you may see one is a tree diagram. You can't make this up. And so what a tree diagram looks like, hi buddy, is something where you start with your two outcomes here. So let's say I'm flipping a coin. I could get heads or tails. And then based off of that, right, I could also get heads or tails. And so this could be continued out for as many branches as possible, depending on how many times you're flipping a coin. Right, so this could have 3, 4, 5, 6 branches, but that's an example of a tree diagram. What's nice about a tree diagram is it tells you how many total outcomes you're going to have in the end, right? So I can see here if I'm flipping a coin twice, I'm going to have 4 possible outcomes. Now, let's get into some basic probability rules here. So the OR rule for probability, and the notation for that looks like this. The probability of A or B, that U is a union, equals the probability of A plus the probability of B minus the probability of A and B. And now the question that you might be thinking is, well, why are we subtracting A and B when or means one or the other or both? The reason for that is that if we think about a Venn diagram here, and if I draw a very rudimentary Venn diagram, that's not what I wanted. My circles apparently need work. Okay, right? If this is my event A and this is my event B, this overlap gets counted twice. It gets counted in the probability of A, and then it also gets counted in the probability of B. So we subtract it out once to make sure we're only counting it one time. Now, the AND rule for probability is the probability of A and B equals the probability of A times the probability of B. And this vertical bar here means given, which is conditional probability, which we're actually going to talk about a little bit more in the next video. But essentially, all that means is the probability of B given that A has already happened. And so it's A times B knowing that A already happened. And this is what I consider to be the general AND rule, meaning this works for every scenario. No matter what the scenario is, this formula will apply. So it's like the quadratic formula of probability rules, meaning it may not always be the fastest way to get your answer, but it is guaranteed to work for you. And like I said, that conditional probability part, we're going to talk about more in an upcoming video. Now, the other important thing about these formulas is, again, they're on your formula sheet. So you do not need to memorize these in the least, but you do need to know when you're going to use each one. So the other important thing that this very first unit talks about is this thing called independent events. Now, all independent events are, right, or we say that events are independent when one event occurring, I'm actually going to say happening because I don't know how to spell occurring, doesn't affect the probability of another one. So two events are independent, essentially, if like when one thing happens, it doesn't change the likelihood that something else is going to happen. So, for example, rolling a die twice, right? Whatever shows up on the first roll of that die does not affect what's going to show up on the second roll of that die. If you're taking cards out of a deck, right? I take one card out of the deck, very specifically, I put it back, and then I take another card out of the deck. Whatever I pulled the first time, as long as I shuffle, doesn't affect what I pull out the second time. What it does change for us is the AND rule, because now my probability of A and B, right, if you remember from before, was this. If the events are independent, this guy right here is now just equal to the probability of B. So if your events are independent, your AND formula is just the multiplication of those two probabilities. Only, and I cannot stress that enough, only if they are independent. So what's nice about this is it's a way that you can check for independence, but also knowing that two events are independent, you can multiply them. And it makes your life a little bit easier. And so that is like the very basic intro to what is probability in AP statistics. So, like I said, you're guaranteed a free response question on this topic. So let's take a look at what some of those questions might look like that maybe only deal with the first intro part of this. And so kind of what I've done is cut up some questions because typically they will start a little bit easier and then get into some of the more advanced concepts. Oh, I lied. I forgot one thing. So the complement of an event is just not that event. So the complement of A is just not A. The complement of heads is tails. Very simple. The formula, and you'll see the notation written this way, is like A with a exponent of C for complement, or I've also seen it as A with a line over the top. I don't really like that one because it looks too much like X bar, like a mean, and that's not what this is. This is just 1 minus the probability of A. That's all. Very, very simple stuff. Now let's actually take a look at this question here. We'll talk about mutually exclusive in a second. So, 9 sales representatives, right? This is from 2014, blah, blah, blah. We've got 6 guys and 3 girls, and we want to send 3 people. And we selected all women. And so, calculate the probability that we get all 3 as women. Now, the nice part about this is you can leave it as a fraction, but the probability that the first one was a woman was 3 out of 9. I can't choose someone again, so now it's 2 out of 8, right? There's 1 less person and 1 less woman, and then 1 out of 7. And so if I actually work this math out, I know the numerator is 6, and if I do this math very quickly in my head, I believe the denominator is 504. That's small, right? And so based on your answer from part A, is there a reason to doubt it? Yes, the probability is very small. So that's an example of a question you might see that just uses your very basic probability rules. Because really, when I look at that first part, 3 out of 9 is the probability of selecting a woman. 2 out of 8 is the probability of selecting a second woman, given that the first was a woman. And then the 1 out of 7 is the same deal. It's the probability of selecting a third, given that the first 2 were women. So we're using that AND formula in the first part. Now, before we go to the second thing, mutually exclusive is very simple. It's just 2 things that cannot happen at the same time. Probability of A and B equals 0. If I was going to draw a Venn diagram, I just can't draw a Venn diagram today. Apparently, this does not like my circles. Oh, that one worked. All right. See if I can get another one. All right, look at me. Right? It would be a Venn diagram where literally it's like this. You have absolutely no overlap at all. Here's A, here's B, and there's absolutely nothing overlapping. Right? So like when you flip a coin, you can't land on heads and tails at the same time. The other word for this that you may see is disjoint, which I actually think is a great word because it helps to illustrate what the Venn diagram looks like. So let's take a look at the last part of this question, right? Which is now we have an alternative probability or an alternative way to try and randomly select here, right? So to try and make this more fair, we're going to roll a die. And if it's a 1, 2, 3, or 4, it's a guy. If it's a 5 or 6, it's a woman, which correlates to the right probabilities. You have a 1/3 chance of picking a woman and a 2/3 chance of picking a man. Does this actually simulate it correctly? The answer here is still no, because this assumes replacement, right? There's always a 2/3 chance that I'm going to pick a guy, right? Or at least when I say replacement, I also mean independence, right? It assumes that there is independence in your selections, but once I pick somebody, I can't pick them again. And so once I pick a guy, there's 1 less guy to choose from. Once I pick a girl, there's 1 less girl to choose from. And so this does not appropriately simulate the process for picking these 3 people. So I hope that was helpful as just a basic overview of what you're going to see with some really basic probability. And we'll dive into some more concepts in the next videos. See you guys then.